We do not experience the world directly. Every feeling, every memory, every sensation is mediated by our neural hardware and software. In fact, our brain is not even trying to represent reality accurately, but uses a set of neural shortcuts and assumptions to allow us to navigate and interact with the world quickly and successfully. Where the physical reality doesn't match the perception in a spectacular way, we talk about illusions. But in fact, it is very rare the case whether we have a good match or a perfect match between perception and reality. For the last 11 years, Steve and I have organized the Best Illusion of the Year contest, where illusion creators from all around the world contribute their illusions, artists, scientists, magicians. Our challenge today is to present you 10 of our favorite illusions from the contest over the next 10 minutes. Each one of them will demonstrate a profound principle by which our brain operates in everyday life. The first illusion that I have for you involves faces. Here you can see a number of celebrities that you will recognize. I need you to look at the central cross and keep your eyes there very precisely, but pay attention to the pictures. And you will see that just in a few seconds, these pictures begin to mutate and they become not so pretty. In fact, they're quite deformed. This is not a computer trick. It's happening in your own minds. To convince yourself, look now directly at the faces, and you will see that they're the same beautiful people you all know and love. Now back to the cross, pay attention to the faces, and they again become pretty ugly indeed. So what's happening? For our brain, there are no absolutes. There is no beautiful, there is no ugly. Everything depends on what you compare it with. And in this illusion, your brains are comparing every single one of these photos with the photo that is coming immediately before and exaggerating the differences.
So I'm going to tell you about this illusion. You look at the two central dots surrounded by dots in the surround, and you'll see that the two central dots look a slightly different size. In fact, they're actually the same size. If we take the central dot out and we move it across the screen, nothing happens as we move this around. Now, the central dot will change size if you look at the yellow dot as the dots in the surround move. But it's a fairly weak effect. We can increase the strength of this now by keep your eyes on the yellow dot in this next demo now, and you can see as you watch the yellow dot, but pay attention to the central dot, ay caramba! It's a very large effect. It's a huge effect. It's only changing in your mind. That central dot is not changing in size. It's all you, baby.
So you can see that whether we're talking about beauty, we're talking about size, everything depends on what you compare it with. This is one of the principles that our brain uses to organize our perception. Another principle is to come up with a lot of information that we make up in the absence of visual cues. Here we have 3 patches of gray. There is not much to look at, but we're going to add just a little bit of context by changing the angle between the 3 patches. And already you can see that we start getting some kind of information. Maybe we see some 3D already happening. What if we add 3 Pac-Man? Now there is an illusory triangle that is happening in your own brains. The triangle does not exist in reality. And if we change again the angle between the patches of gray, now the triangle becomes a pyramid and then becomes a triangle again. So we have a very complex percept with just minimum visual information.
This illusion is an illusion about adaptation and after images. So you can see 2 identical stars here, one on the left and one on the right. Now the star on the left is made up of both of them are made up of pink star and a green star at different angles. Now, as you look at the one, say, on the left, and just stare at it, when it turns off, you'll see that the background has a shape in it, and that shape is filled with color. That's an after image. You'll notice that the one on the opposite side of the screen has a different color, but that's impossible. It's an after image of the same image on both sides. It has something to do with the shape of the stars that's giving you the differential colors. Now, what'll really blow your mind and keep you up at night is if you look at the center of the stars, you'll notice that it's not really green and pink being transparent and seeing through them. It's really just a gray field there. There was never any color in the center of this star. Yet you're seeing individual stars in your after image be pink or green. Your brain is filling that in completely on your own.
Our brains need to handle visual ambiguity all the time, and ambiguity is indeed critical to many illusions, such as this one here. The two sets of chess pieces, top and bottom, are exactly identical, yet the top looks white and the bottom looks dark. Everything that changes is the context. In the next slide, we have 4 circles on the left, 4 on the right. Again, the ones on the left look very dark, the ones on the right look very white. Everything is exactly the same in the circles, pixel by pixel. Here in the moon that is moving is exactly again the same. All that changes is the clouds surrounding them.
Here we have 2 towers of Pisa. You'll notice the one on the right is leaning more than the one on the left, but that's completely in your mind. It's not true. They're actually identical photographs. What's happening here is when something leans back and away from you in real life, if you have 2 of them, they should converge. They get closer to each other in real life. But with 2 photographs, which we're not evolved to look at, they stay physically parallel on your eye. Okay? So what your brain is doing is when it sees 2 things leaning away from you and into the distance, and it stays parallel exactly and not diverging, it realizes it must be they really are diverging from each other. So your brain is telling you these towers are diverging when in fact they're not. And it doesn't just work with buildings going off into the sky. If you have roads that you have to point at, what I want you to do is I want you to always point at the one that doesn't match the other. Okay? Go ahead, put it out and point at the one that doesn't match. Okay? No, point at the other one. Now, come on, are you a mix I can or a mix I can't? Point at the one that doesn't match. It's very difficult. The reason it's difficult is because of your perceptual system. You'll notice that 2 of them actually are the same, and if we line them up with the other, that one was exactly different, even though it looked the same just a second ago.
So it's all a matter of perspective. And in this illusion, you can see that things can look quite different depending on your point of view. So we have 4 ramps. They're made out of cardboard. And we're going to see a few balls made out of wood that are rolling uphill onto the ramps. There are no magnets involved. There is no CGI magic. This is a real physical object. But we're looking at it from the wrong perspective. Let's turn it around for a different view. And you see that, in fact, the balls have been rolling downhill all along.
Here we have a donut of blinking, changing color dots. If you look in the center, you'll notice that when the donut turns, the blinking stops. And then it starts again when the turning begins again. It's actually not true. The blinking's happening all the time. You're just not seeing it because if you look in the center, when the thing turns, your attentional system of your brain is paying attention to the motion and not the blinking. And one of the things that we've noticed in our research about the brain with our colleagues is that the attentional system can only pay attention to one thing at a time. You can't do multitasking. So when you pay attention to the turning, you can't see the blinking. Now, to prove it to yourself, look at one of the blinking dots and just pay attention to that as it turns, and you'll see that it keeps blinking the whole time. But you couldn't see it when you weren't paying attention to that.
We started off with an illusion about faces, and we want to finish with another illusion involving faces. Here we have 2 self-portraits by Rembrandt and Van Gogh. You can see that the portraits look quite different. The style is different. The colors are different. Or are they? In fact, the colors are exactly the same, left and right. Only the luminance differs between the 2 paintings. We can convince ourselves, but by superimposing them again and swapping them, So you can see that they match either way. Your brain is assigning the right color to the right shape. We all learned as children to color inside the lines, but that's not necessary for the brain. Our brain can assign color to shape even if the lines don't match precisely. And it works also with landscapes. Here we have a forest and a Manhattan skyline. They look different again, but the colors are exactly identical once more. And if we make them go back up and even swap, you can see that our brain, again, assigns the colors as needed to the correct shapes. We have run out of time, but time is an illusion. And I think Andres will understand
Andres, it's an illusion.
if we go on and show you an extra additional illusion that a lot of you may recognize it. This is the infamous dress that almost broke the internet a few months ago. All right. Before we move on, I just need to ask, how many of you see the dress as white and gold? How about as blue and black?
Loca!
How about as something else? Well, the fact is, none of you are completely wrong. Let's talk about what the science of the dress is for a few minutes.
Okay, so what's going on here is in fact something we don't know the true story for. Scientists are studying this very vigorously right now. We don't know all of the answers about this. We don't know why half of you see it as white and gold and half of you see it as blue and black. But we do know how you can potentially see a blue and black dress as either white and gold or blue and black. So let's talk about that. So here's two examples. The one on the left is a blue dress, and the one on the right is the white and gold dress. Now, in fact, the two right halves of each of these dresses is exactly the same on your retina. The only difference is inside your brain. It has to do with context. So in the blue dress on the left, what's happening is the part on the right appears to be under sunlight, and so you interpret that as blue and black under sunlight. Whereas the one on the right is white and gold, but it appears to be in the shade on the right, and so you interpret it as a white and gold dress under the shade. If we take that to real life and we put two physically identical photographs, this is actually the photograph of the actual dress from the photo that melted the internet, and put it on two models, one that looks like she's in the sunlight and one that looks like she's in the shade, you actually see these dresses as different colors. Again, all because of the way your mind works, okay? Now, what this means is that if we take a blue and black dress and under white lighting, it's unambiguously blue and black, and now we put it under a blue light source like the sky, or a yellow-white source like the sun, then you can see that the one that's under the sun is the thing that can be ambiguous. Now, why does that happen? It happens because our color vision, our eyesight, only developed to see color under the sunny sky. We only could see color during the daytime throughout all of history up until a few hundred years ago. Okay? So we actually have neural systems that are there in order to discount blue light from the sky and yellow light from the sun in order to see things more accurately. And that's why this particular dress melted the internet.
Some illusions are impossible to overcome. Even if we know intellectually that a certain object is a different color or a different size than what we see, we still struggle to see it any other way. The illusion is hardwired into our neural architecture. So perhaps, however, it's not important that we try to overcome illusions. They're doing some important things for us. They make us quicker, more efficient, they increase our focus. What's the point? The point is that even if there are certain limits to how much we can change our perception, understanding what those limits are and the neural mechanisms that produce them is very important, because once we know, we can apply the same loopholes to make ourselves more productive, more successful, and even happier in our everyday lives. To the brain, the same exact object can look pitch dark or blindingly white. Is your glass half empty or half full? To the brain, it's mainly a matter of context and perspective. Muchas gracias, Puebla.
Gracias.